Morning class. Today we will discuss the doubts of the worksheet given to you. Important questions were there. So whatever question you are feeling problem, I will try to solve it here. Okay. So our first question was of worksheet 1. Find the zeros and verify the relationship between the zeros and the coefficients. Clear? So the last part was fourth part. Equation polynomial was given to you 3a square x square plus 8abx plus 4b square, right? What you are finding? You are finding problem is how to separate this polynomial, right? Separating the middle term, okay? So I'll tell you it will be same as we are done in rest of the questions. See the multiplication of these two, 3a square x square and 4b square. What is the multiplication? A square x square multiplied by 4b square is equals to 12a square b square x square. Okay. Now I want to split this into two numbers so that the multiplication becomes 12a square b square and x square, right? So for that we are just 12, look for 12 only, okay, otherwise the every term will get 8. 6 and 2, 6 and 2 will make 8, adding 6 and 2 will give you answer 8, right, and the multiplication will give you answer 12. So here I am writing 3a square x square as it is plus 6, this term should be abx plus 2abx, then only like term we will be able to add now, okay, then only this will become 8abx, right. So 4b square, okay. Now next step is taking common from these two and these two terms, right, first two terms and last two terms. What is common in these two? 3 is common, 3 is a common factor, right. A we are getting common, right. X is common, x square here it is, this is x. So we are writing x here. So what we are left with in first term? X only and ax plus 3 is common, so 2 is left here, a is cancelled, x is cancelled, so here left b, okay. Now take common from these two. What is common? 2 is common, then b is common, clear. So what we are left here? Ax plus b only and 2b, okay, this is 4, here we have taken common 2, so here we are left with 2 and 1b, clear. So this bracket is same now, so let it take out as a common factor 2b and 3ax plus 2b. So now we are looking for zeros of the polynomial. How to get the zeros of the polynomial? Keep each factor is equals to 0 individually. Ax plus 2b is equals to 0 and 3ax plus 2b is equals to 0. Here ax is equals to minus 2b and x value is minus 2b upon a. Clear? Another value of x, put a semicolon in between. Here it is 3ax is equals to minus 2b, x is equals to minus 2b upon 3a. So we are getting two values. This you can write as alpha, alpha is minus 2b upon a. Let's write this as beta. It is minus 2b upon 3a. Clear? Right? Now we have to verify the relation. Okay, here we will do the verification of the relation. Clear? Before that we will write a, b and c, value of a, b and c. Value of a is what? Here I will use capital A because already we have small a, b existing over here. So capital A is this 3a square, capital B will be 8ab and capital C is 4b square. Clear? Now What was the relationship? Sum of zeros, alpha plus beta, it should be equals to minus b upon a. Let's verify this. Alpha and beta, add them up. Alpha plus beta will give you minus 2b upon a plus 2b, here again it is minus, okay, so negative sign, upon 3a. Let's take LCM, minus 2b upon a minus 2b upon 3a. LCM will be 3a, this will become minus 6b and this is 2b. So altogether this is minus 8b upon 3a. Clear? Now let's check what is minus b upon a. What is my minus b upon a from this equation? Minus b upon a is, yes, 8ab, minus 8ab upon a is what? 3a square. 3a square, capital A I am using, okay. So this a and a are cancelled out. So what we are left? 8b minus and 3a. So finally we have verified the sum, okay. Sum of zeros equals to minus b upon a. Hence verified. Now we will see the product, okay. For product, let's write up. This side is visible, I think, right? Alpha into beta. Alpha into beta. What it is? Product of these two. It is equals to minus 2b upon a multiplied by minus 2b upon 3a. Beta's value minus 2b upon 3a. Clear? So it will be equals to 4b square upon 3a square. Right? So what is c upon a from here? C upon a is same. Capital C upon capital A is same. 4b square upon 3a square. Here this and this both are same. Hence we can write alpha into beta is equals to c upon a. Product of zeros is equals to constant upon coefficient of x square. So this was your first doubt in the relationship, verifying the relationship. Let's see the next one. Next question is question number 3 in your worksheet. Worksheet 1. Px square plus 2 root 3x plus q. This polynomial is given to you and it is said that root 3 and minus 3 root 3 are the zeros of this polynomial. You have to find the value of p and q. Clear? Here we will use the relationship again. What was the relationship? Sum of zeros. Let me take this zeros as alpha. Let alpha is equals to root 3 and beta is equals to minus 3 root 3. Okay. We know sum of zeros, alpha plus beta, it should be equals to minus b upon a. It means sum of these two, alpha is root 3, put the value minus 3 root 3, it should be equals to minus b upon a. Minus b is minus 2 root 3, okay. This is a, this is b and this is c. Clear? So here it is minus 2 root 3 is equals to upon a is p, right? Minus 2 root 3 upon p. Let's do the cross multiplication. P will be equals to minus 2 root 3 upon minus 2 root 3, that is 1. Clear? So p's value is 1, right? Now the another relationship was alpha into beta is equals to c upon a. It means we need to multiply these two zeros. Root 3 into minus 3 root 3. It will be equals to c. C is q. Q upon a. A is p. Okay. So now you can put the value of p1. P is 1. Clear? So what it is? Minus 3 and root 3 whole square. You solve it like this. Root 3 2 times, so root 3 whole square. This minus 3 is here this side, okay, in the beginning. P's value we can put 1, right? What it is? Minus 3 into 3 is equals to Q, that is minus 9 is equals to Q. This is the value of P and Q. Clear? So, one more question of worksheet 1 we will solve right now. Okay, then we will move to worksheet 2. Note it down. Question number 7 of worksheet 1. Here you are given with one biquadratic x4 minus 6x cube minus 26x square plus 138x minus 35, and two of its zeros are given. These are two zeros. Which one? 2 plus root 3 and 2 minus root 3 are the zeros of this polynomial. Okay, what you need to find? You need to find the remaining two zeros. It is biquadratic, so it will have 4 zeros at the most, okay, in which 2 are given, right, and 2 are asked to find, right. So, first of all, we are making use of these two, okay. If zeros are given, so we can change it into factor form by using factor theorem. X minus of this term, 2 plus root 3, and x minus of this number, 2 minus root 3 are the factors of given polynomial. So, if these are the factors, let me simplify it once. What will be this? X minus 2 minus root 3, and this will be x minus 2 plus root 3 are the factors of this polynomial. Watch them carefully. This is your A, observe it as B. This is your A and this is your B. So, what you are getting? A minus B, A plus B. First term minus second term, first term plus second term. This is identity, A minus B, and here it is A plus B. So, formula is A square minus B square. So, it will become x minus 2 square minus root 3 square. Just we are simplifying up to the factor to get a proper polynomial to divide, okay. So, what it is? It will be x square plus 4 minus 4x, and this will give you minus 3. So, finally, we are getting what? Yes, x square minus 4x plus 1. Yes, okay. So, here we will divide the polynomial. This has finally came as factor of this polynomial. After simplifying these two factors or multiplying these two factors, finally we are getting a quadratic polynomial as a factor of this polynomial, right. Now, what we need to do? We are doing division of this polynomial by this polynomial. X4 minus 6x cube minus 26x square plus 138x minus 35. Divide by x square minus 4x plus 1. First it will go for x square, multiply by x square because we want x power 4, right. So, x4, this multiply this is minus 4x cube and this will be plus x square. Clear? Now, do the subtraction. This is minus, this is plus and this is minus. These two are cancelled and here we are getting minus 2x cube minus 27x square plus 138x minus 35. Clear? So, now we need to multiply it by minus 2x, right, because here we need power 3 and coefficient minus 2. So, we are multiplying it by minus 2 and x. What we are getting? Minus 2x cube and plus 8x square and minus 2x. Clear? So what we are getting finally, add, subtract and addition sign. These two are cancelled. This will be minus 35 x square plus 140 x minus 35. Is it clear? Right? Now the same power we are getting, so we need to multiply it by 35 only, this polynomial. Okay, so we are multiplying it by 35. This will be minus 35 x square, this and this, for 20, 0, 2, 12, 140. 140 exactly, 140x. This multiply this is minus 35. So you can see all the terms are same, and when we will change their sign, all the terms will get cancelled, right? So finally this polynomial was a factor of this polynomial, so we are getting remainder 0. Okay, so now we have to utilize this. Okay, let's make use of this quotient, x square minus 2x minus 35. Okay, we want to split it into two factors so that the multiplication should be minus 35x square. So we are splitting it, x square minus 7x plus 5x minus 35. Okay, so take common from these two. Here's x is common, this will be x minus 7, 5 is common, and here it is x minus 7. Bracket is same, this is a common factor, so here we are left with x plus 5. So finally two more factors we are getting out of this polynomial. Clear? So what are the remaining zeros? How to find zeros? Keep this factor equals to 0. Okay, this will be x is equals to 7 and here it will be x is equals to minus 5. So these two are our remaining two zeros of this given polynomial. I hope is clear to you. One more question, this you will find in your optional exercise of NCERT, right? This says same statement is given there. One NCERT question of exercise 2.3 of same type I want to tell you, right? There just hint I am giving you. You are given with root 5 I think and upon 3 and minus root 5 upon 3 as the zeros of the polynomial, right? From here how you will make the factors? X minus root 5 upon 3 and this will be x minus of minus root 5 upon 3. Okay, and this will be x minus root 5 upon 3. This is x plus root 5 upon 3. This is your NCERT question of exercise 2.3. Okay, I guess some of you are having problem in this type of question because here it is given in fractions. So I think I should discuss it, right? So this will be x square minus root 5 upon 3 square. Clear? What it is? X square minus 5 upon 3. Now you are confused where to divide this polynomial with the given biquadratic, right? How to divide this fractional part. So need not to worry, you will be taking LCM here. Okay, 3x square minus 5. Clear? So here you will be dividing the given polynomial by 3x square minus 5. Okay, write your biquadratic here, whatever is given, and then you will be able, because hardly matters, already this is factor, if this whole is factor then this is again factor of given polynomial. So you just divide it, the given polynomial, by this factor only, 3x square minus 5. Okay, and that will be more simpler and easier for you. Clear? So this was about your one doubt of exercise 2.3. I hope it is clear. Now we will move to worksheet 2. Okay, worksheet 2. Just write it down and then we will discuss. Let's discuss this statement, I think second last of your worksheet 2. If alpha and beta are the zeros of the polynomial 2x square minus 3x plus 5, then form a polynomial. We need to form our own polynomial as our answer, whose zeros are 3 alpha and 3 beta. Okay. Alpha and beta, these zeros are of this polynomial. Clear? Alpha and beta are the zeros of this polynomial, and one more polynomial as a answer we have to create. Okay. So, solution is alpha and beta, if they are zeros, are the zeros of polynomial 2x square minus 3x plus 5. So, what can we write sum of zeros from here? Alpha plus beta will be equals to minus of minus 3 upon 2, that is minus b upon 2, and this is equals to 3 upon 2. Alpha into beta will be equals to 5 by 2 c upon a, no? 5 by 2. Okay. These two relationships we are getting it from these zeros and this polynomial. Clear? Now, we have to work for a polynomial whose zeros are this. So, let me write, let capital S and capital P are the sum and product of the polynomial of the required polynomial whose zeros are 3 alpha and 3 beta. Let me take S and P as the sum and product of the polynomial whose zeros are 3 alpha and 3 beta. So, product of zeros, okay, sum and product of zeros of the required polynomial you can write. Okay, you may change this sentence like 1 minute. Let S and P are the sum and product of zeros of required polynomial, whatever you like. Okay. Okay, this is the sum and P is the product of the zeros of the required polynomial. So, S will be equals to 3 alpha plus 3 beta. Okay. So, take 3 common, alpha plus beta, right. This alpha plus beta we can substitute its value from up, that will be 9 by 2. P is the product of 3 alpha and 3 beta. It will be 9 alpha beta. Okay, 9 alpha beta's value we can write from up, 9 into 5 upon 2, that is 45 by 2. I hope it's clear, right. Now, the required polynomial, we know how to write required polynomial. What was the formula? K times x square minus sx plus p, sum and product. Sum and product already we have found. Okay, so let's write it here, k into x square, s is minus 9 upon 2, x plus p, product is 45 upon 2. Clear? Let's take 2 as LCM. 2x. Okay, this will be 9x and plus 45. K's value you can put as 2 and finally you will be getting 2 into 2x square minus 9x plus 45 upon 2. 2's are cancelled and the required polynomial answer is 2x square minus 9x plus 45. This is your required polynomial. Okay. Let me brief you once again what we have done exactly. We have utilized these two zeros of this polynomial. We have utilized the relationship between the zeros and the coefficients. Okay. Okay. This much is over. Right. Up to here we have utilized alpha plus beta 3 upon a and alpha into beta 5 upon a. Clear? These values we will use further. Okay, while we are writing the polynomial. Okay, we have taken S and P and the sum because we know how to write a polynomial k x square minus sx plus p. This is a formula to write a polynomial. But what is this x? Sum of the zeros of the required polynomial. What is this p? P is the product of the zeros of the required polynomial. Okay, zeros of the required polynomial are these two. So we have found here sum and product of the required zero first of all. Okay, first you have to find this S and P, then we will be substituting over here. Okay, I hope it is clear to you. Okay, again you can ask the same doubt if it is still not clear. Okay, so note it down, then we will discuss next. So here is another statement. If the zeros of the polynomial ax square plus bx plus c are in the ratio 2:5, prove that 10b square is equals to 49ac. This relation you have to show. Clear? What is given? Polynomial is given. No zero is given. Just they are saying the zeros are in the ratio 2:5. This we have to use. Okay. So let me first take, whenever the ratios are given, we can consider the zeros, right? You have done question related to age. If Mohan and Sohan's age is given to be 2:5, then what we take? 2x and 5x. Clear? So similar way we are going for this. Let 2 alpha comma 5 alpha are the zeros of polynomial ax square plus bx plus c, right? Ratios of the zeros are given. So I have taken or I have considered or assume the zeros as 2 alpha and 5 alpha, okay, of this polynomial. Now let us use the sum and product. Sum of zeros. Sum of zeros we know is equals to minus b upon a. Okay. So sum 5 alpha, it should be minus b. Here it is minus b only. Okay, because this is given to be general form of quadratic polynomial. So b will be same b, right? So this is 7 alpha is equals to minus b upon a. If I write alpha's value, then what is alpha? Minus b upon a 7 times. Clear? Or you may write minus b upon 7a, right? Now we are using product of zeros. Product of zeros is equals to c upon a. Fine. So here use 2 alpha into 5 alpha is equals to c upon a. This is 10 alpha square is equals to c upon a. So we can substitute the value of alpha. Yes, 10 into minus b upon 7a square is equals to c upon a. Clear? So what it is? 10b square upon 49a square is equals to c upon a. Let's do the cross multiplication. This a will go up. What it will become? Let me show you here this side. This will be, or you can say a and a are cancelled, right? 10b square upon 4a is equals to c. So 10b square is equals to 4ac. 49 this is. This is 49a square. One a is cancelled. So we are left with 49a. Clear? So 49a and c multiplied. So this relation has come. What we don't need to prove? 10b square is equals to 49ac. So this was all about your doubts of chapter number 2, polynomials. Now we will revise, or I guide you to do optional exercise even. Okay, if you find again any problem, you can ask it. Thank you. Have a nice day.